students, my name is Purva Sharma, Assistant Professor of Physics at Biyani Girls College. Today I am going to discuss on the topic combination of capacitors. First of all, we should know that what is capacitor. Capacitor is an electronic component that has the ability to store the charge. Now capacitors can be connected in two ways. One is the series and second one is the parallel. Now let us consider the first case, the series case. In series case, there are actually many capacitance can be connected in a circuit. There can be n capacitance in a circuit, but we are considering here only 3 capacitance, and we will derive the equation for the equivalent capacitance for the 3 capacitors, and then we will write the general formula for the capacitance when connected in series. So let us consider that 3 capacitors are connected in series to a battery. Now if we see the diagram, then we can see that the first plate of the first capacitor is connected to the battery, and second plate of the first capacitor is connected to the first plate of the second capacitor. Second plate of the second capacitor is connected to the first plate of the third capacitor, and so on. Now plus Q charge will be supplied by the battery to the first plate of the first condenser. So the first plate will have the plus Q charge due to this battery. Now due to the induction, negative charge will be induced on the second plate of the first capacitor. Similarly, first plate of second capacitor will have plus Q charge, and first plate of third capacitor will also have plus Q charge, and second plate of second capacitor and third capacitor will have minus Q charge. Now let us start the derivation. We know that according to equation that Q is proportional to V and Q is equals to CV. From this equation we can get the value of V as Q by C. So since we know that V is equals to Q by C, now for capacitor C1, if we talk about this capacitor, then for capacitor C1, here the voltage is V1, for capacitor C2 voltage is V2, and for capacitor C3 voltage is V3. So V1 for capacitor C1, V1 will be equals to Q by C1, because the charge will be the same in all the 3 capacitors. So Q will be the same in all the 3 cases, and what will vary is V will vary and capacitance will vary. So if we write for the first capacitor, then V1 will be equals to Q by C1. For capacitor C2, the voltage is V2. So for capacitor C2, V2 will be equals to Q by C2. So V2 is equals to Q by C2. For capacitor C3, voltage is V3. So V3 will be equals to Q by C3. Let this equation, let main equation be equation number first. For capacitor C1, it will be equation number second, equation number third, and equation number fourth. Now the total potential difference across this whole circuit, we know since it is written over there that the total potential is V. So this potential V will be equal to the sum of all the potentials. So V will be equals to V1 plus V2 plus V3. So V is equals to V1 plus V2 plus V3. Let this equation be equation number 5th. Now let us use all these equation in equation number 5th, that is using equation 1st, 2nd, 3rd, 4th in equation number 5th. So here first term is V, and V is equals to Q by C. So Q by C. Second term is V1. V1 is equals to Q by C1. So Q by C1 plus V2 means Q by C2 plus V3 means Q by C3. Now Q is there in all the terms, that is on the LHS also and on the RHS also. So we can take Q as a common, and if we take Q common, then Q will be cancelled out on both the sides, left hand side and right hand side. Then 1 over C is equals to 1 by C1 plus 1 by C2 and plus 1 by C3. This is the formula when there are 3 capacitors are connected in a series. So this is the general formula for the capacitance when connected in series. Now let us consider another case, but that is the second case when the capacitors are connected in parallel. So this is the diagram for the capacitors connected in parallel. here also we have taken 3 capacitors, then we will solve the equation for the 3 capacitors and then we will write the general formula. So 3 capacitors are connected in parallel. This is the capacitor C1, C2 and C3. In this we can see that the first plate of all the 3 capacitors are connected to a common point and the second plate of all the 3 capacitors are connected to another common point. And the first plate of all the 3 capacitor will have plus Q charge, and second plate of all the 3 capacitor will have negative charge, that is minus Q. Now for we know that Q is equals to CV. So for capacitor C1, now in this case, in the series case we know that Q was same in all the 3 cases. Now in this case Q will be different in all the 3 capacitors and V will be the same in all the 3 cases. So for capacitor C1, Q1 will be equals to C1V. For capacitor C2, Q2 is equals to C2V, and for capacitor C3, Q3 is equals to C3V. This thing you have to remember that in series Q will be same, okay, and in this parallel case V will be same. Okay, now we have determined Q1, Q2 and Q3. Now this is equation first, second, third and fourth. Now the total charge, if total charge flowing in this whole circuit is Q, then this Q will be equals to Q1 plus Q2 plus Q3. Now using equation number first, second, third, fourth in equation number fifth. So in place of this Q we can write CV. So CV, in place of Q1 we can write C1V, Q2 C2V and Q3 as C3V. Now V can be taken as common from both the sides, then C will be equals to C1 plus C2 plus C3. So this is the formula when the 3 capacitors are connected in parallel. Now let us see the general formula. So general formula C is equals to C1 plus C2 plus C3 up to Cn. Thank you, and please don't forget to share, like and subscribe on our YouTube channel.